All right. Hello, everybody. Good morning, good afternoon. Warm welcome from our side. My name is Albert Cott. I'm going to be the presenter today. I'm a market development engineer here in Pilz headquarters. And we will wait. People is still joining. Yeah. Meanwhile, we start. Just feel free to ask any question or comment request. We have here as a backup our product manager, Chris Baumeister, who is the product manager of some of the products that you will see today. And he is in the question side. So we have at the end a short spot to talk about the questions and answers. But just in case, if you have any questions, just go ahead and use this tool, this GoToWebinar tool to do so. All right, hope you hear me loud and clear. And yeah, we'll start. Good. So this is the agenda for today. We have basically 5 points. First of all, we'll start with why you might require a key in pocket solution. And afterwards, we will go for the what is exactly the key in pocket solution. So what are the components, what is the solution, the procedure, etc. Okay. Afterwards, we will talk about the applications that can be used and the benefits that this solution have in this application. And finally, we will have a live demonstration here. We will go through all those components and we will see how they work on the functionality. Okay. Good. This presentation more or less will take about 25, 30 minutes. All right. Finally, we will have a questions and answers. Good. Let's start. Why would you need a solution like the key in pocket? And we have collected different feedback and different remarks from the market, from you all, that we would like to share, and we would like to explain you how the key in pocket and our identification and access management solution fits to those daily challenges and to those statements. Okay, the first one is this one coming from electrical manager, and it's saying basically that I want to prevent accidents, therefore all the workplaces must meet all the normative, the standards requirements. Okay. The second statement is coming from the maintenance manager, and it's basically saying that under his responsibility, only qualified employees with the appropriate certifications, with appropriate trainings, can have access to the machinery. The third one is coming, of course, from the production manager, and it's basically saying that so the systems must run, of course, 24/7, and they do not have to fail in case of some manipulations. And the last one is coming from a company CEO, and it's explaining that only our valuable corporate know-how must be protected from illegal access. And yeah, if we start from the beginning, here we see in the left side, I want to prevent accidents, and of course this solution should be based on the standards and the requirements, and that's how our key in pocket solution works. So basically it has a PLD category 3 certification coming from TÜV. We have a slide for that. So it fits on the requirements and standards based on the 13849 and the 62063. Okay, so we are providing an employee protection because it's based on the standards, the typical standards of the machinery. Then the second point, and it's also important, our key in pocket solution can identify who is going to have access, and we can allow or deny the access to the machinery, to the dangerous area. And therefore, we can know if somebody is qualified or not to have access to that area. Therefore, we are also providing a liability protection. Afterwards, as we are identifying who is the personnel, we may know if this personnel have training or not to have access. Therefore, if they have training, they will be more productive since they know what they have to do inside a dangerous area. So the production time will be as much as possible. Therefore, we are also providing a productivity protection. And last but not least, as again, we are identifying who is the personnel who wants to have access, to the data or to an area. We can also provide data protection. Okay, so those are the 4 values that we are providing in the identification and access management, and therefore we are also providing them with the key in pocket solution. All right, now let's go deeper on what really is the key in pocket, what are the components, what are the process, and so on. And let's start with an initial situation. Okay, to make it easy, we would like to explain you that we may have a dangerous area, a machine, a robot cell, which is protected by metal fences. And normally this type of machine have a door in order to go inside and do some maintenance work inside. Okay, what we want to protect is that if somebody is going inside that area, and meanwhile this person is inside that area, somebody come and close the door and tries to restart, the system should not restart. Therefore, because there is somebody inside, of course, and there is dangerous movement, and this is a high risk for the personnel, and that's what we are trying to solve, and that's why we have today the key in pocket solution. Okay, so here we have the initial situation, and now we will explain the solution approach. And our solution approach is quite easy to understand. We have a sign in, sign out procedure. So if I want to go inside the dangerous area, I have to sign in the door or in the electrical cabinet. Once I have signed in with a RFID key, that I don't know if you can see right here, those are the RFID keys. Once I have signed in, then my security ID is directly stored safely in a safety controller. This means that the safety controller knows who is inside the dangerous area. Therefore, the safety controller will not allow to restart the machine if there is somebody inside, if there is somebody in this safe list. Okay, once I have done my task inside the dangerous area, inside the machine, then I can go out, close the door, and sign out. Once I sign out, then my security ID, let's say, will be deleted from the safety list of the safety controller, and then the machine is ready to restart. And you can see it in the pictures that we have below. So we have the sign in, then this personnel is going inside, and finally we have the sign out just to allow the system to restart safely. Okay, so that's basically the solution approach that we have. And as I was mentioning before, our solution is certified. So this process, together with our access management solution and the safety controller, is certified with a PLD category 3 based on the 13849 and a SIL 2 based on the 62061. Okay, this certification is coming from TÜV, and you can find it in our eShop. Good. Now that we understand and know the basics and the process of the solution, of the clean pocket solution, now we will go through the different components. Okay, the first and most important one is our PIT reader. This is our device, which is taking the information from the keys and sending it to the safety controller. Okay, as you can see here, we have different devices for different types of keys. Okay, so we have the transponder key, but we also have cards, as you can see here in the left side. Okay, so basically, as said, this device will understand who wants to go inside the area. We'll see how many permissions, if this person is allowed or not to go inside, and then this device will transport all this information to the safety controller. So let's talk about the safety controller here. Those are the safety controllers from Pilz, which can be used in our solution, in our key in pocket solution. First of all, we have the Peanuts Multi, which is the safety configurable relay. And then we have also our safety PLC ESS 4000. Okay, in those PLCs, aside from controlling the overall safety of the machine, they also have a safety block, which is called safe list. Okay, and in this safe list, they will store up to 20 users in this safe list, which means that for a machine, we can sign in up to 20 people. Good. Okay, so those are the mandatory products that have to be used in the key in pocket solution. And then in the left side, we have the accessories that might be also useful to use, of course, which first of all is an LED and a push button in order to sign in and sign out. This can be used with our Fit gate box, which have the e-stop and different buttons to sign in and sign out. And then the LEDs are also important in order to know if I'm signed in or not. So just to have some communication to the operator. Okay, and then we have other ways to visualize and communicate the information of the key in pocket to the operators. First of all, we have the pass visual, which is the visualization part, and those are our displays, our HMIs, and we can use them to see how many people is inside and also who is inside the area. And then another solution, if we do not have any HMI to display this information, is the Verma light. Okay, in this e-sign LED lamp, we can indicate how many people is inside the area. So we can easily explain to the operator how many people, if there is 1, 2, or 3 persons inside the area. Okay, here maybe it's easier to understand in this slide, where in the left side we have the Vermalite in the overall green, and this means that there is nobody inside and the machine is producing, and so on. Okay, and if somebody wants to sign in, then we have 1 person here, two people, and three people. Okay, so that could be another option to visualize easily how many people is inside. And in the right side, here we have how it looks like with our EMI, with our display. And as you can see in the picture that I'm showing here, we can see that there are 3 persons inside, and on the bottom we can see who is the person inside, right? So we see the security ID, and then if with a simple database we can know the security ID who is for internal information. Good. So but you can, of course, you can tell me that there exist other functions of restart prevention systems in the market, and we took and we classified like the classical solutions and procedures and our key in pocket solution, and we would like to explain you why. Okay, so in the classical solutions and procedures, we have the local backup systems. We have also electronic keys like the peace and code switch key from our side, where you take the key with you, go inside, and once you have finished, you insert the key again, kind of a trapped key system. That's another solution that, of course, it's available today from other competitors, from other providers. And we would like to explain you why the key in pocket solution is different. And it's mainly because we are not only providing a solution for the restart prevention, but we are also providing a layer of identification. And that's something unique, because we know who is going to go inside the area. And this means that we can allow or deny the access depending on the qualifications and trainings. And this is something that with the existing procedures today is not possible. Everybody can go take 1 key, it doesn't matter if it's electronic or mechanical, and go inside the area, right? But with our key in pocket solution, we can also allow or not this based on qualifications. And this is something completely unique. Good. All right, let's talk now about the applications and the benefits on those sectors and applications. Okay, and it's quite difficult to fit this solution in one industry or different industries, right? I mean, basically, this restart prevention solution might be used in large areas, large spaces where there is no clear visualization on who is inside the area, so it's not clear when could personnel and operator restart or not the machine. And we have explained here maybe the basics one, which is the automotive industry, robotic application, it doesn't matter the industry, intralogistics world, and so on. All right. And let's jump into some benefits that we have, for instance, in the robotic sector. And first of all, again, is the knowledge advantage that we have. So as mentioned, we know who wants to go inside the dangerous area, and we can allow them or not. But we are also can track this information, and we can know who was in the dangerous area and when it was. So it's also useful for the KPIs and so on from the production side. Okay, then we have the flexibility advantage, and As mentioned before, we can track up to 20 people in a safe list, and this means that it's completely flexible. So it doesn't not matter on, in the mechanical trap keys systems. If you have 5 keys in the door, then you can only go inside with 5 people, and not 6. So it's quite fixed, the number of people who can go inside the dangerous area. In our case, it's completely flexible. It doesn't matter. Up to 20 people, of course. And then we are also flexible in blocking the access. So for instance, if there is a person who cannot have access today or for the next week, we can block temporarily the access to the dangerous area. Okay. And then we have the blind spot detection, which is basically if there is a blind spot around a machine that it needs to be checked before signing out, because it can be that somebody is there and we cannot see it. We have also a safety block in our controller to check the blind spot detection. Okay, I will go through this blind spot afterwards while we were talking about the live demonstration. Good, and some other interesting advantages that we have. First of all, the speed advantage. So it can happen that somebody loses the key or forgets it at home. So it's quite easy to reprogram a key in order to restart quickly. Okay, so that's something easy, fast, and it's in order to restart. Yeah. Then we have the price advantage, because those keys are not made of metal; they are RFID keys. So the pricing compared to the mechanical keys are quite more competitive, our system. Okay, and last but not least, we have the most important advantage, which is the application advantage, because with our solution, we can go inside an area from one door and we can get out from another door. So this is basically more efficient in terms of production, because I do not need to go in and out from the same door. So it's also an application advantage and a flexibility advantage for you all. All right. Good. And then if we go deeply in one type of application, which is the rail dependent storage, as you know, this is coming from a standard Type-C 528, and this standard is explaining basically a set of other things. It's explaining different mitigations requirements, and the first mitigation that you can see over here is that we have to prevent the risk of being trapped inside the mobile area with the whole body access. Okay, that's the first thing that we have to prevent. Then the second is that we have to provide means of an escape release. So in case of that I am locked inside, I need a solution in case of getting me outside that area. And last but not least, we have to also prevent the unauthorized access to the automated storage and retrieval systems. Okay, so this is how it looks like. This graphic is coming directly from the standard, and we can see here in the number 1 we have an operating mode to change to automatic to manual. So if I want to go inside the dangerous area, which is basically this mobile part over here, I have to change it to automatic to manual, right? So afterwards I will need to go to a door, open that door, get inside the mobile, so the dangerous area, and here change again the manual mode to automatic mode again, right? So I will need to do that, and once I have finished, I should go outside and restart the machine. Good. So this is how our solution looks like overall. So in the left side, we have the PID reader, which here is doing more than one thing. First of all, is doing the key in pocket solution, let me say, because we will do the sign in, sign out when I want to go inside the area, right, in order to prevent the unexpected startup. Then the PID reader is also doing the safe operating mode selection. So the PID reader is changing the automatical to manual mode in a safe way again. Okay, this is everything controlled by our Peanuts multi safety controller, which is also taking care of the other safety devices, which are the PCM block, like you can see here, or the gate box with the e-stops and so on. So this is just for you to get a brief understanding of how our systems, our products can fit in an overall solution. Good. So here we have our final slide before going to the live demonstration, and this is just to explain you the overall system before we explain it practically. Okay, so here in the door side, which is basically this guy over here, we have the PCM block with the door handle module. And then we have the PIT gate box, which is the guy who have the e-stop, couple of push buttons, and our reader over here in the third part. Then we have the safety controller that we have it over here, which is taking care of the overall functionality of the system. And last but not least, you can see here in number 2, we have the blind spot detection or check. And as you can see here, maybe if I'm just sitting right here and I want to restart, I'm not sure if there is somebody here or not. So I'm not sure if I can do the restart or not. And that's why we have a push button. So in order to restart the machine, I would need to go there to acknowledge that there is nobody inside. And by this acknowledge, I would mean to press the push button. And then I would have a limited time to go outside, close the door, lock it, and sign out. Therefore, I would be able to restart the machine. Okay, and that's exactly the procedure that I would like to show you right now. Okay, so I would just basically stop sharing the screen. So now you see me full screen, hopefully. And yeah, right. And first of all, I would like to show you, and I'm gonna move here. Yeah, perfect. How the system look like if I have access or not. For instance, with this key, we have programmed that this key, this person, do not have access. Okay, and I don't know if you can see it, but yeah, there is an LED in red. So basically, this speed reader, this device is not sending any information to the controller because it doesn't matter. You are not allowed. You don't have the right permissions to get inside. Okay, so this is basically how we block a personnel without any qualifications to get inside. And now, if the right person comes and just push in the RFID key with the right permissions, then this guy will be able to start again. So here you see an LED, which is basically the green one, explaining that the machine is running. Then if I want to go inside, I would sign in. And now as you can have heard it, the machine has stopped, and now the system is unlocked. So I can go inside. Okay, I would go inside, sorry for this, and I would take the key with me. So I can do the job, I can do the work that I have to do, right? I will self. And now once I have done all the functionalities, all the things, all the tasks that I have to do, then I would press here. You cannot see it, but we have a push button. I would press the push button, and now I have a limited time. So I have checked in the blind spot that there is nobody, and I have now a limited time to go outside, to close the door, to sign myself out. It's this key. I would close the door, and now I would sign myself out, and now the system is ready to restart. So as you can see, we have sign in and sign out, and then we have go inside. We have check, acknowledge that there is nobody in the blind spot area, and then we have gone out. We have signed out, and yeah, the machine now is ready to restart. So this is a simple use case with only one door. If we have different doors, the functionality, the process can vary a little bit, the way that we open, close, lock, unlock the door. So this is up to the use case, and that's why it's quite interesting for you all to know that this safety controller has the safety block, and this can be adapted and flexible to the requirements and functionalities of the use case. Okay, so that was everything that I wanted to explain. I'm going to show it again. Good. And now we will jump into the questions and answers. Yeah. So, Chris, is there any question that I would? Okay. So a colleague here is asking what happens if during a maintenance, one person leaves the factory. So somebody has signed in and then they leave the factory and he has not signed out. So of course, the ID would be stored here in the safety controller, but this person is just now having dinner happily and the system cannot be restarted. That's why we have also a safety block inside the safety controller, which is deleting the safe list. Okay, and that's another use case. It might happen this. So we have thought on that, and the solution is to use this deleting this safe list. Okay, we normally would advise that in order to delete this safe list, somebody with a high permission, high level, has access only to this functionality, right? So that's what we can do to delete the safe list. Okay, thanks for the question. The complete presentation will be shared afterwards. We will take the people who has participate and we will send you the presentation afterwards, correct? So there is another question. Good, there is one question. If, yeah, he says, great, one blind spot, but what about multiple over a large area? And this is also possible. Okay, we just not only have one blind spot, it's just a safety block. Then you can use and you can call it several times. So you have 20 blind spots, then you will need to have 20 push buttons to acknowledge the 20 places, and all of those will go into 20 blind spot blocks. Okay, it's saying 20, but it can be more or less. So one person is asking is if it's possible to enter in one door and exit in another door, and that's a solution that we can provide as well. So if we have a use case on a machine with 5 doors, it's completely possible to get inside from one door and get outside from the other door. So we are providing here an effective and efficient way to get in and out depending on the maintenance requirement and needs. There is another colleague who is asking if it's possible to have 2 keys with the same ID, right? So that's not possible. It's every RFID key that we are providing has their unique ID. So this situation is not possible for our system. All right. So I think it's everything, Chris. Yeah. Okay, a colleague is asking what happens in an emergency case if someone is in and needs help. This can happen with or without a restart prevention solution. Somebody needs help. It doesn't matter if it's in the dangerous area or not. So I guess this is up to the end user to decide how to provide support and help inside the dangerous area. Yeah, for instance, of course, if somebody's locked in with our systems, we have also the escape release. So just in case that somebody's locked inside and he cannot get out, we have with our systems we have escape release, and it's in the bottom part of the system, and it's in red, so it's clearly identified by just pressing the escape release and getting out of the system. Okay, so the question now is how do we program the system? How do we know who has access? And basically that's the job of the pit reader. In the pit reader, we decide in which permission can somebody get in or not. So imagine that the operators have permission 1, and then the maintenance guys or the service guys have permission 2, 3, or 4. We can program these into the bit reader and then allow the access for the personnel who has more than permission 1. And if they have permission 1, it will be like this, that situation that we have explained before, and the system will not allow you. So at the end, it's up to the bit reader. The safety controller will not decide if you can get in or not. It will be the bit reader. Okay. Good. Is there anything else, Chris? Good. Thank you so much for your questions. That was very interesting to hear and to answer them. Stop sharing. And that will be everything from our side. As said, afterwards we will send you out the presentation, and you will have our contact just in case that you have any question or comment request. We will be happy to support you afterwards. So yeah, thank you so much for participating in the webinar, and yeah, have a nice day or a nice evening. All right, take care. Bye.